This video is for page 17 of your interactive notebook about isotopes and average atomic mass. An isotope is an atom of the same element that has different numbers of neutrons, and therefore isotopes will have different atomic masses. So for example, if I had two carbon atoms, and each of them had a different number of neutrons, let's say one of them had 6 neutrons and one of them had 8 neutrons, we would consider these carbon atoms to be isotopes. They're both carbon, meaning that they both have 6 protons in the nucleus, but one of them has 6 neutrons, giving it a mass of 12, that would be carbon 12, and the other one has a mass of 14 because it has 8 neutrons, and we would call that carbon 14. We have a special notation whenever we write an isotope, and we're going to discuss that symbol here on the left. Isotopes are denoted using this notation, where we have the element symbol with the atomic mass number written to the top left of it, and the atomic number written to the bottom left. It's very important to note here that this is the atomic mass number, not the average atomic mass. The average atomic mass we're going to discuss in just a moment on this page. So this is not going to be the number that you find on the periodic table, but rather the atomic mass number for the particular isotope that you're writing an isotopic notation for. For example, an isotope of carbon with a mass of 14 AMU. Well, we know by looking at the periodic table that carbon has 6 protons because it has an atomic number of 6. And if its mass is 14 AMU, and we know that the mass is equal to the number of protons plus the number of neutrons, we can determine that it would have 8 neutrons. But to write the isotopic notation, all we really need is the atomic mass number and the atomic number. So for this particular atom, we're going to write the symbol C for carbon with the atomic number 6 to the bottom left and the atomic mass number 14 to the top left. Okay, so a moment ago I differentiated atomic mass number from average atomic mass. So right now we're going to talk about average atomic mass. On the periodic table, the number that you actually see as the mass is the average atomic mass. And what this is a weighted average of the masses of all of the different isotopes of an element based on their relative abundance. Because after all, not all carbon is carbon 12, and not all carbon is carbon 14. And a sample of carbon is going to have some atoms of carbon 12 and some atoms of carbon 14, and even some atoms of other carbon isotopes. So the average mass of carbon then, which comes out to be about 12.011 AMU, is an average of all of the different isotopes, but the key is that it's a weighted average, meaning that the most abundant isotopes are going to affect the average more, and the least abundant isotopes, the more rare ones, are going to affect the average less. Relative abundance is the percent of each isotope found within nature expressed as a decimal. So for example, if a sample of carbon from nature was 99.5% carbon 12, then we would take that percent abundance, 99.5, and express it as a decimal, 0.995, to get the relative abundance. Again, this is the mass that you're going to find on the periodic table, the average atomic mass, and we can calculate the average atomic mass by taking the mass of the first isotope and multiplying it by its relative abundance, and adding that to the mass of the second isotope multiplied by its relative abundance, and adding that to the mass of the third isotope multiplied by its relative abundance, and so on and so forth, for however many isotopes we have of that particular atom. On the left, we're going to look at an example problem for calculating average atomic mass. The example reads, rubidium has 2 common isotopes, rubidium-85 and rubidium-87. If the percent abundance of rubidium-85 is 72.2% and the percent abundance of rubidium-87 is 27.8%, what is the average atomic mass of rubidium? It's first important to determine the relative abundance of each, since what we're given is the percent abundance. Because the percent abundance of rubidium-85 is 72.2%, its relative abundance will be 0.722. The relative abundance of rubidium-87 will be 0.278. Now we're going to plug these into the formula. Remember that the average atomic mass is the mass of the first isotope times its relative abundance plus the mass of the second isotope times its relative abundance. And because we only have 2 common isotopes for rubidium, that's as far as we have to take the formula. We could add a 3rd, 4th, 5th isotope if we needed to, but in this case we don't. So the average atomic mass is going to be equal to the mass of the first isotope, 85, times its relative abundance, 0.722. And we're going to add that to the mass of the second isotope, 87, multiplied by its relative abundance, 0.278. Once we do that, we're going to get an average atomic mass of 85.6 AMU. And if you look at your periodic table, you'll note that this is pretty close to the published value. We're going to practice this on the average atomic mass worksheet. There's 5 problems here that I want you to complete, and the first one we've done in class, as you can see. But finish the rest for homework, glue this into the left page of your interactive notebook on page 17, and you'll be done with isotopes and average atomic mass.